We will not have the quizzes and the regular schedule, right? So I'll just upload the tentative dates.
Okay, sir. Okay, sir.
Yeah. Okay, so this is the next topic, projections of planes. And as I had mentioned in the earlier class also, for all these projections, effectively what we have to make use of this angles or corners. Please switch on your microphone. Somebody is microphone on. Please switch it off. Somebody has kept it on. Mute it, please. Yeah. So every time, whatever we do, I mean, whichever projections we'll be discussing afterwards. So every time, what we actually do is we consider these projections in terms of points only. Like in case of lines, most of the times, what we are doing is we are trying to look at the end points or maybe some other point which is lying on the line and then proceeding. So the same will be the case for planes as well. So generally we'll try to consider the corners associated with the plane figure, and then we'll try to locate them, and joining them will be obtaining the views, front view, top view, right? So like that will be proceeding. Then one more thing is that uh, generally, as somebody had pointed out in the mm, class also, that which angle projection will follow and so on. So that thing now will be useful for us. So as we have discussed already, if any object is placed in the first quadrant, then the front view will lie above the XY line, top view will lie below the XY line, right? And then if object is in the second quadrant, then the front view and top view both will be above the XY line. If it is placed in the third quadrant, then front view will be below the XY line and top view will be above the XY line. And when we place an object in the fourth quadrant, then front view as well as top view both will be below the XY line. So that means if the object is placed in the first quadrant and or else if it is placed in the third quadrant. For these two cases, the front view and top view are at the opposite sides of the XY line. But for the case of,
Excuse me, sir.
yes,
Sir, are you drawing something on paper? Because we can only see the title, that projection of plane, something
I
like
am
that.
discussing only so far.
Okay, okay, sir. Sorry, sir.
Hmm. Yeah. So please mute your microphone. I don't know who. Some people join while keeping them unmuted. Please mute yourself before joining the session. Okay. So what we were discussing. Yes, so when we place, I mean, considering placement of the object in any of the four planes, oh, sorry, four quadrants. So first quadrant and third quadrant give us the top view and front view on either sides of the XY line. But if it is in second or fourth quadrant, they will be overlapping. And because of this reason, generally, now, I mean, henceforth, I mean, projection of planes onward will be generally uh, either having the cases of object lying in first quadrant or third quadrant. Or say when solving any problem, if we have choice, then we'll end up choosing either first quadrant or third quadrant to place the object. Okay. Now, before proceeding further, let us have a look at the different types of plane figures. Now these are, let's say, different possible plane figures. Mostly everyone of you knows these. Just for the sake of recollection, let us have a look at them again. So you have this hmm, any triangular shape with no sides equal to each other, an equilateral, all the sides equal, isosceles with two sides equal. So these are the three possibilities with the triangles. Then we could have quadrilaterals, right? So we could have one where no sides have no corresponding say similarities or relations, right? Or we could have a trapezium, so the opposite sides will be parallel to each other. We could have parallelogram, both the pairs of opposite sides parallel to each other. Then a rhombus, all sides equal, and additionally the diagonals are also perpendicular to each other and bisect each other. Then there could be rectangle. For this, of course, you know the properties, right? Then these are some other regular polygons. So one is regular pentagon, regular hexagon, regular heptagon, or octagon. So generally, of course, you know all these. But these whatever like these included angle here, here. So these things actually we need to use if say if you are asked, or say if you are given that okay, there is a regular pentagon, it is having 30 mm side, then what will happen? You'll you'll have to draw it, and then for that you will need these included angles, right? And of course, generally it would be a good practice to locate the geometric center, make a circle, and then have these distances marked on it. That would be a better choice. Then you will be actually drawing it very accurately. So anyhow, so the purpose of this slide is that we recall these, and then also these plane figures usually have some associated features which we'll have to keep in mind, so that while solving a problem, we need to make use of those associated features of the planes, right? And then these are some commonly used plane shapes, right? Which we will actually be using. One more thing let me mention, and please keep it in mind. When we are considering projections of planes, then we can imagine, okay, all these planes are in general, say, transparent. That we can by default go, because by definition planes don't have what do you call, thickness, right? So planes in general don't have thickness, so taking that into consideration, we can imagine them to be transparent. And also one more thing, whatever these projections henceforth for the planes will consider, so they are in general, these regular shapes will be considered because they are easy to draw, or any description associated with them generally will be easy to express. Okay, fine. Next, here are some simple cases. On the slides, in general, using a rectangle, things have been depicted. And the reason is that, of course, making a rectangle on slides is relatively easier. Of course, will actually be coming across all possible shapes, whatever we have seen in the previous slides. So this first one, as you can see, represents the case when this rectangle is a rectangular plane figure is perpendicular to the vertical plane, and it is also perpendicular to the horizontal plane. So it's effectively perpendicular to both the planes, and we end up having line view in for both the cases. So front view is also a line and top view is also a line. And likewise, in the second figure, a plane figure is parallel to the horizontal plane. So, and of course it is by default then, if it is say it is a plane figure and it is parallel to horizontal plane, then of course it will be perpendicular to the vertical plane. So for this case, again a line view we obtain in the front view, and in the top view. Yes, please mute yourself. Who is Balwant Rai? Hmm. Yeah. So this plane figure will remain perpendicular to the vertical plane by default, and therefore here we get the line view, and then top view gives us the true shape. So whatever are the exact dimensions included angles of this plane figure, the same will be visible in the top view. So from here, one thing, okay, I think let us have a look at the next slide also, then we'll talk about it. Here, these projections have been given in the figures, and here the pictorial representation has been given. Yeah, now let us see this next case. Here, first of all, this is the same thing what we have seen in the previous slide. Plane figure is parallel to the horizontal plane and by default becomes perpendicular to the what do you call vertical plane. So here a line view and here the true shape. Now consider this one. Here what's the position of this? Again, it is still remaining perpendicular to the vertical plane, but this is now not parallel to the horizontal plane. So now,
Yes.
Yes, sir. Yes, sir.
okay, yeah. So yeah, what we were discussing, right? So this again, if we compare these two, so here still the plane is perpendicular to this vertical plane, right? But it is inclined to the horizontal plane, therefore the overall size of this figure is reduced. It's not the true shape anymore, right? So now let us consider a case that we have been given the position of object like this. Okay, if it is an what do you call a rectangle, whatever is depicted here is a rectangle. So suppose if it is a rectangle, then of course you will be able to draw it in this position directly. By directly, what I mean is, as long as you know that how much is the inclination of this surface with the horizontal plane, you will be able to draw line view because it is perpendicular to it. And if at all you have kept these two sides such that these are giving point views, okay, so you will be able to draw this line, and then you will be able to project the top view. I mean, I actually discussed based on this pictorial presentation, but what I'm talking about is this final answer, right? So you can draw an inclined line here, and then corresponding to these projectors, you will be able to have this reduced size of this figure. So this could be, this is a possibility. But say if our shape is not this much simple, it is not a rectangle, it is some other shape, maybe a pentagon suppose, then directly we won't be able to draw for such a position, right? What I mean is, suppose this one of the edges is given to be say parallel to horizontal plane, but the surface is inclined, then this is the reduced top view. So say if the shape is a pentagon, we won't be able to directly draw this pentagon, right? Because it will have reduced dimensions of its sides. But if at all we have been given such a condition which corresponds to this inclined plane as depicted in this, then we can obtain this by drawing it in two steps. First we follow this step and then this, right? So here what is there? Here initially this plane figure is parallel to the horizontal plane. Apart from that, what? While being parallel to the horizontal plane, it has got these two shorter edges perpendicular to the vertical plane. The surface as such is perpendicular to the vertical plane. Apart from that, what? These shorter edges are also perpendicular to the vertical plane. Okay. So if we choose such a position, then this is the top view and front view combination. So A and B placed like this give a point view here. C and D are also giving point view here. And this plane figure is giving a line view in the front view. Okay. Now when this actually is to be inclined, then this line or this line view in the front view obtained can be drawn inclined, and then what we can do is we can draw the projectors from here and here. Then we'll have the reduced rectangle available as the top view. So directly we cannot draw this, and as I had mentioned, for rectangle it will be a specific case we can draw, but for other intricate shapes it might not be possible to draw directly this second step. But if we draw the first step like this, then the second step
Why
is
that is inclined?
why that is inclined. It has been placed like that. We are trying to consider, say, some generalized kind of positioning of the plane.
Sir, can't we place it another way?
Listen to me first. Yeah, what I'm saying is it can be, say, a plane figure can be placed in some fashion in the, say, first or third quadrant or wherever, right? And then its projections suppose are to be obtained. So for that case, we won't be able to directly draw that, right? So that is why what we are doing is we are considering that suppose we have been given some kind of positioning for this, then what we have to do, first of all, we have to keep it like this, okay? And thereafter we have to change it to this position. So here what we are discussing is a simpler case, and then we'll go to the next case, that is next after this. So there we might require more than 2 steps. There we might require 3 steps. Okay. So placement can be of any kind, right? But of course, for the sake of possibilities, or say to the extent it can be described with the information in text, right? There will be, of course, certain limitation on its different possible orientations. But whatever orientation is given to us, right? Based on that, we'll have to obtain the front view and top view. That is what we'll have to do, right? And we cannot directly reach to that because one of the reasons we saw here, the reduced top view directly we cannot draw. So what we'll do is we'll first consider a simpler thing and then move on to the next one. So like this we'll have to proceed. Maybe so we can now consider next example. Yeah, okay. Before that, one more thing let me mention again. We have discussed it as well. See, so as to obtain these projections, as I had mentioned, we'll have to first consider the location of the corners of the object. That will remain an essential feature. Once we look at them, then we can identify those in the change position or in the front view and top view. We look at all the corner points and then we join them so as to obtain the front view and top view. That is how we will proceed. Now, this transition from first to second position, what we have considered, for that, one more thing, let me say more clearly or specifically mention. See, from this step, the first step, this has been considered parallel to the horizontal plane. In this step, it is inclined to the horizontal plane. So the transition from this to this on the drawing sheet, right here, of course, looking at this picture and this picture, I hope it is clear to everybody. But when we have to draw it, then you see from here to here, what we are doing is we are first of all changing the position of this line view. We are making it inclined. Okay. Since the plane has given us a line view in the front view, that is why what is happening? It is easy to show it inclined here, right? Getting my point? This is perpendicular to VP, we got a line view. So here it was a line parallel to the XY line, and it represented the case when the plane was parallel to horizontal plane and perpendicular to VP. Here plane is perpendicular to the VP but inclined to the horizontal plane. So this line is, that is this front view, which is a line, is drawn inclined. When we draw it inclined, it will be up to this A dash B dash will be at this location only. For the trace it has been extended here, so please ignore it for the moment. Yes, so this point and this point, these represent the two endpoints for this configuration. And now we can draw projector from here and projector from here, right? Now on these projectors, this A1 and B1, here both A and B in the front view are coincident, but here they are at different locations. So of course one possibility is that this edge, what we can do, whatever length is available, we can draw it here. But for rest of the diagram in general, what we can do is whatever are the distances of these points, like this D is how much away from this XY line. So that distance we can make use of, and from here that distance can be marked on this projector to locate D1. This C is how much away from XY line. So that distance we make use of to locate C1. So like this we can locate all this. And of course the logic behind this is when we change this orientation of the plane figure from this position to this position, what we are trying to do is we are keeping this plane figure at the same distance away from the vertical plane, and only we are making it inclined. So say this edge is kept at its location constantly, so it's kept here constantly, and only the other this edge is then rotated about this, so that this inclined configuration is obtained. So when this change is occurring by keeping this edge at its position, if this position of this edge is not altered, then what will happen? All these corners 1 2 3 4 will maintain the same distance from the vertical plane in this position as well as in this position. Okay, so same will be valid here also. So here whatever distances of these corner points from the XY line will have, their distances from the XY line in this also will remain same. Okay. Yeah, so let us proceed further. So please read this problem. This is obstructing. Can I move it? It's difficult. Okay, so we have a regular pentagon of 20 mm side. Okay, and as one of this also I need to, yeah, as one of the side on the ground. Okay, so that means if we consider horizontal plane to be the ground, then one of the sides is on the ground. Its plane is inclined 45 degrees. So its plane means it is a regular pentagon, so its surface actually is inclined at 45 degrees to the HP and perpendicular to the VP. So this precisely represents the same thing whatever we discussed in the previous slide, right? So the plane is inclined with the horizontal plane and is a perpendicular to the vertical plane, and we have to obtain the projections. Sorry, I forgot to discuss the traces in the previous slide. Yeah. So now for this case, as we discussed in the previous slide, now directly for this inclination 45 degrees, we won't have the two dimensions of the sides of the pentagon available to us. Okay, so That is why what we need to do is initially we need to assume it parallel to the horizontal plane, or else here one side is on the ground. So since in the final position one side of the pentagon is on the ground, so we can assume the complete pentagon to lie in the horizontal plane in the first position. And in the second position, what we'll do is we'll try to obtain this inclination. Okay. So first of all, we have to place the pentagon in the horizontal plane, number one thing. Second thing is to keep one of its side perpendicular to the vertical plane. So you see, like this. So keeping this side perpendicular to this XY line. So here the intention is to consider this as the top view. Okay. So what we are doing is we are assuming that this is on the horizontal plane. Okay. And then while drawing this, so here true shape will be available when it is placed on the horizontal plane. So top view will give us the true shape of the pentagon. Side is given to you, included angle you know. So then you will have to draw the pentagon. Okay. Then while doing this, we have to also keep this line perpendicular to XY so that this endpoint and this endpoint both will actually uh, get coincident while we draw the front view. So this is a 25 mm side pentagon, and all the corner points you can give some suitable names, A, B, C, D, E. So then these names can be consistently used because we'll have to draw one more diagram as such, right? Now if we say draw projectors from all these corners, then we'll get them on this XY line, and that will be then joining them we'll get the front view. So these projectors drawn from here, and then you get this corner point. So A and E at the same location, B and D at the same location, and C over here. So you get a straight line. Everything we will consider in the what do you call XY line only, and the reason is that it will be we are considering it to be on the horizontal plane, so that is why this front view we are supposed to obtain only on the XY line. So you get these corners, okay, A dash, E dash, B dash, D dash, C dash. So as we discussed initially, A and E both we proceeded until the first step. So let me bring it over here fast. Yeah. So yeah, what we were discussing is, you see this in this diagram, what we have done is we have kept the plane first of all parallel to the first of all on the horizontal plane, because the condition is that one of the edges is on the ground. So what we have done is we initially kept the complete figure on the ground or on the horizontal plane, and while placing it like this, we have also kept one edge perpendicular to the XY line. So this will be equivalent to considering that this edge will be perpendicular to the vertical plane. Okay. So with this, what is the advantage you can see? Now, if I change anything, orientation of this front view. If I change the orientation of this front view, let me change this to pointer also. You guys always insist on it. Yeah. So if I change the orientation, so that of course front view as such is a line, so that will be equivalent to just changing the inclination of the line with the XY line. So that will give the change in the orientation of the front view, right? And when I do so, the plane will continue to remain perpendicular to the vertical plane. as long as this front view is a line view, and then whatever orientation I give to it, it will continue to remain perpendicular to the vertical plane. That's what I mean from the pictorial presentation on the previous slide we have seen. So that is one thing. Second thing is, if say this change in orientation, when I incorporate this change in orientation, this point of the front view I keep at the same location. I don't change the position of this point. And then rest of the front view, which is a line, is rotated. Say this corner I pull up here, so it will be equivalent to rotating this line about this center. It will acquire some position over here. When we do so, you see this point has not changed its position. It is remaining on the XY line, and that will amount to the fact that this AE will continue to remain on the horizontal plane. Okay, let me repeat, or say let us see this second diagram. So when we have changed the orientation, we did not change the location of this point. It is remaining here only. In the next step, this is remaining here only. So you see this point actually is representing an edge, and that is why this edge represented by this point is still on the horizontal plane. Okay, and also when we have done this exercise, what we have done is we have not changed anything about the position of this AE. So this change from this position to this position, whenever it is occurring, these distances of A from XY here, B from XY here, C from XY here, these are not getting altered. Okay, it is rotated about this plane figure is rotated about this, so these distances are not altered, only orientation is changed. So to obtain corresponding to this new inclined front view, to obtain the top view, what we need to do is we need to draw the projectors from here, because like C dash is here, so C, that is the top view of C, will be on the same projector. So we can draw a projector from here. We can draw a projector likewise from here to have B dash and D dash. Projector, from here to have A and E. Sorry, here whatever we have, that will be without dash, that is for the top view. And also after drawing these projectors, we'll also have to draw lines parallel to XY from here. So these will give us the same distance from the XY line for these corresponding corner points. Okay. So yeah, this 45-degree inclination as per the question obtained here, then we draw these lines. So after projecting these, because these projectors will contain the top views, and then we have to draw these lines here. So like A is to be at this much distance, so we draw this line, then this same distance we achieve here. So here we will mark small a. Okay, if you draw another line from here, so here you will mark small e, and so on. So like this, all the corner points will be located. If we join these, then we can complete the top view. You see here one more thing, as we had discussed, if this front view is a line view but inclined, then what is happening? Then this reduced size for the top view is being obtained. Okay, so directly we won't be able to draw it. So that is why what we do is we initially draw it like this, then obtain this. So here this initial position therefore remains crucial, right? Here like you have to, one thing what we did, we kept it on the horizontal plane, and we kept this edge perpendicular to the VP, or in the top view perpendicular to the XY line, so that we are not only obtained the front view as a line view, we also obtained this edge as in the form of point view. This only allowed us to obtain this renewed position while keeping this in the same plane. Okay, so that is how we solve for this case. Okay. The traces I had forgotten to discuss for this. Maybe as such for planes, traces are not likely to be of much use, but sometimes their location might be given with reference to the traces. So maybe in tomorrow's class we'll discuss that. Let us have a look at the next problem now. Yes, again, let me shift it slightly so that I can read. So draw the projections of a circle of 5 centimeter diameter. Okay, having its draw the projections of a circle of 5 centimeter diameter, having its plane vertical and inclined at 30 degree to VP. Okay, so plane is vertical. Number one thing, plane is vertical. So that means the plane is perpendicular to the horizontal plane. That is one thing. Second thing is it is inclined 30 degrees to VP. So it is vertical and then inclined 30 degree to the vertical plane. So problem is similar. In the previous problem, inclination was of the plane was with the horizontal plane, but it was perpendicular to the vertical plane. So here that thing has been reversed. So it is perpendicular to the horizontal plane and inclined with the vertical plane. So that is the situation. Then its center is 3 centimeter above the HP and 2 centimeter in front of the VP. So the position of the center has been given so that we can what do you call we can locate the center. Then diameter is given, so we can then consider that how the overall circle is situated, right? Now this for this case, again for the initial position, what we need to consider, the surface is having some inclination with the vertical plane and the plane in itself is perpendicular to the horizontal plane. So in the initial position, we should assume that the plane is on the vertical plane or else it is parallel to the vertical plane. So when this plane figure will be parallel to the vertical plane, what will happen? We'll have the true shape and size available in the front view. Okay. Now this center is 3 centimeter above the HP. So this condition we can fulfill in the first step itself. We can keep we draw as XY line, and then above the XY line we place the center of the circle at a 3 centimeter distance. Okay. So 30 mm. Okay. Diameter 50 and the circle drawn, right? So actually when you draw at 30 mm, you'll locate the center and then you'll draw the circle like that we have to do. Now corresponding to this, of course, we can obtain the top view. Simply you will have one projector from here, one projector from here, and on the horizontal plane we can obtain. If it is assumed to be on the what do you call? If it is assumed to be on the vertical plane, on the horizontal plane, the top view can be obtained. Otherwise, if you consider this position directly, then we assume that this is parallel to the vertical plane. For that case also, front view will remain the same. On the vertical plane or parallel to vertical plane, for both the cases, true shape will be available. So the front view will not get altered. Okay. And then only difference in the top view will be if it is on the vertical plane, top view is on the XY line. If it is parallel to the vertical plane, then you will be away from the XY line, but it will be a line parallel to the XY line, like that, the top view. Fine. Now we don't have corners for this, right? For this diagram, we don't have any corners. So for this front view and top view, for this position, it is all fine. But when there will be some inclination, we won't have a regular circular shape. So we will not be able to draw it. So that is why we'll need to have some corners or some points generated on this circle so that we will be able to draw the next steps. Okay, so what we are doing here is we are dividing it into some equal numbers. So usually if you make 12 divisions, that would be best. Okay, here it is shown like that. So if we make 12 divisions, then on the periphery of this circle, right here, you'll have all these points located very well. And then with reference to these points, we'll be able to actually continue further. Okay, so these are the points. So we can simply consider these as the front view: 7 dash, 8 dash, 9 dash, 1 dash, 2 dash, 3 dash, right? Now we project it. This is the distance up where the center is to lie. So taking that distance here, we actually project it all here. So all the points projected here, and we get the top view, right? So eventually you see, for except for this first and last, I mean this 1 and 7, for every projector we are getting 2 points when we are having 12 divisions. Okay, so now the front view and top view for this case is available. Next we have to maintain this condition, this 30-degree inclination with the vertical plane. So that we do here. So it has been drawn at 30 degrees. Center has to be 2 centimeter in front of VP. So this center here, it will be coincident with 4 and 10. The center is coincident with 4 and 10 at this location. So this has been kept at a distance 2 centimeter in front of VP, and therefore here below the XY line 2 centimeter. Okay, then at 30 degree, this top view is reproduced. At 30 degree, we again draw the top view, inclined 30 degree. Now the same thing what we had discussed, if this change from here to here is being done by keeping the rest of the figure at the same level as far as its distances from the horizontal plane is concerned. So this center is not changing the position, it will be this 30 mm away only, and then it has been twisted like this, it has been rotated like this. So now you project it all above, and these distances will remain same, right? Because that is how we have rotated this circle. So you locate all these corner points like this 2 and 6 on the same level. You draw this line, intersection of this line and the projector from this 2. This gives us corresponding 2. Likewise, 6 is on the same line, and 6 here is at this location. From here you draw a vertical line, the intersection locates 6. So likewise for the 4, right, and 10. So this way we'll locate one by one all the points. Okay, all the 12 points once located, then you have to join them freehand, and you will, of course, you already know this is a what do you call, this is an ellipse. So with freehand you will have to draw this. So this completes the final position. So next class, of course, I'll have to proceed further, right? Now this will be for considering any third step, that is when the position is not which can be achieved with 2 steps, and will require a third step also. So that we'll discuss tomorrow. Okay, so it will be a regular lecture. Okay, and if we complete it tomorrow, then this projection of planes will be your next tutorial sheet for the practical session. Okay, and any doubts will session will consider on Wednesday. Okay, so I stop now. Okay, bye bye.